reaction, what I hear around the room is very, very good. You're doing a nice job summarizing your similarities and differences between your conclusion on 4-8. So that's great. I want you to keep doing that if you're not done yet. But if you are done and ready to move on, I'm going to go ahead and let you copy down our vocabulary for today. So if you're still talking with your neighbor about some of your similarities and differences in your parabolas, finish that discussion, and then I'd like you to take some time to copy down your vocabulary, please. Not done with your vocabulary? Is that what you're saying? Okay. So let's walk through a little bit more about this vocabulary. I might have you add a couple things in. In going over the homework, I learned that my class kind of already has an idea of what a parabola looks like. You get the idea that it is indeed a U-shaped graph. When you go ahead and identify things for a parabola, the first thing we actually tend to think about is that axis of symmetry, or the line of symmetry. And you might recall all parabolas are going to have these lines of symmetry, because if you remember from geometry, lines of symmetry are just places where we can fold things in half. We don't have any funny edges sticking out. Parabolas have these too. They're going to be vertical lines that run right down the center of the parabola, and I can fold it in half and I wouldn't have any funny edges sticking out. To be very specific, it's just a line that's going to pass through a point we call the vertex. We have a formula associated with an axis of symmetry. I'm going to go ahead and share that with you now. It is a formula that looks a little something like this. It's going to be a vertical line, right? A vertical line, so it's going to be x equals, we know that when it's x equals a number, that's a vertical line. And on the other side of that equal sign, we have the opposite of b, all over 2 times a. And this is the formula you're going to need to remember out of today's lesson. It should look a little bit familiar to you. It is part of the quadratic formula. And we'll talk about how that relates to this, maybe a little bit at the end of class today. You can use the line of symmetry to identify the vertex of the parabola. I'm going to show you how to do that today. And as you write down your formula for your line of symmetry, you're probably thinking, where did this A and this B come from? And I'm just going to remind you about this vocabulary term you dropped down up here. Remember, we always write our quadratics in standard form to start off, so decreasing order for your exponents. The A is going to be the number in front of the x squared. B is going to be your number in front of x. C is going to be the constant tagged on to the end. Ultimately, when you go to graph tonight, because you're only graphing so many problems, I want you to keep in mind that if it says graph, you're not just throwing it into your calculator and getting the little U-shaped squiggle and putting it on your paper and then calling it a day. When a problem or a homework assignment says the word graph, I said in the past you could let out a little groan, right? Because these are the problems that take us a little bit more time, because there are certain points we have to identify. Those points, you might recall, are what we called critical, whoa, not critical woe. That's not what that's called. They're called critical points. Do you remember what type of points we classify as critical points? Dylan. So the vertex, which is often called a max or a min, x-intercept or steps. Remember, sometimes you won't have them at all. If your discriminant is a negative number, you're not going to have any real zeros. You're not going to have any of those x-intercepts. And then your y-intercept. There's only ever going to be one of these. If you think about it, you have more than one y-intercept, it's not a function anymore. It would fail that vertical line test. So you can only ever have one y-intercept. These are the things, the general checklist of things that you're going to go ahead and graph when you go to graph a parabola. So, when you go to do an assignment for tonight, or do your assignment for tonight, you could set up your graph paper so that it looks like this. You'll copy the problem. In this case, our problem is y equals negative x squared plus 4x minus 3. And you're going to find for me like this little checklist of things. Thing number 1 we're going to work on is the LOS. That's my abbreviation for line of symmetry. So that's going to be the first thing you're going to find. Why I find that first is because it helps me identify what the point is for the vertex. After I do the vertex, I take some time to calculate what my y-intercept and x-intercepts are, And then I also jot down the domain and range after I look at the graph. I will be very honest with you, when you take your test around next Wednesday-ish, the problem just says graph, but none of this checklist is here. So the expectation is it's like an essay question for you. Do you know what parts to graph when it says graph a parabola? So it's just going to have the equation there. You have to remember all of the parts you have to find. So I just wanted to give you a heads up that that might be something you want to, keep in the back of your mind, maybe study before you take your test. And we'll talk about this lots and lots and lots. So hopefully you'll get some good practice. Step 1, I go ahead and find the LOS, or the line of symmetry. I have a formula for that. It is x equals negative b over 2 times a. And when I look at this problem up here, I see a is negative 1, b is 4, and c is negative 3. So if I want to do the opposite of b, that'll be negative 4 over 2 times a. It's 2 times negative 1. I'm going to simplify that denominator a little bit. That'll be negative 2. And then if I simplify negative 4 divided by negative 2, that is 2. So my axis of symmetry, or line of symmetry, is a vertical line at x equals 2. When I draw this in, I draw it as a dashed line, because you might recall from previous chapters that dashed lines aren't actually solution points to our graph. You draw it and you label it. So that is x equals 2. Next up, I need to calculate the vertex. Vertex, by definition, must be a point on this line. So it's super easy to find. All I have to do is take my x value from my axis of symmetry and plug it into my equation. So I'm going to go ahead and evaluate my function at x equals 2, which means that wherever I see an x, I'm going to put in a 2. I then do my order of operations. I'm going to square my 2, make it negative, add 8 to it, subtract 3. So addition and subtraction get done in the order that you see them. Negative 4 and 8 is 4. 4 minus 3 is 1. So when I put 2 in, I got 1 back out. That is the coordinate for my vertex. So I'm going to plot that point, and I'm going to label it. Over 2, up 1. Notice it says, hey, tell me if it's a max or a min. You would just circle one of those, right? I'm going to go ahead and give you a little trick. It's very similar to the way we decided whether or not our parabola, or I'm sorry, our absolute value function opened up or down. If you remember with absolute value functions, if your a value was positive, your v opened up. But if your a value was negative, your v opened down. Let me add another little bit to that. In general, I like to teach this as like my parabolas are either going to smile or they're going to frown. And if you're a person that smiles a lot, you can tend to think that your personality is more on the positive side. If you're a positive person, you smile. Well, I look at my a value here, and I'm like, well, that's not a positive number. That's a negative number. Negative people don't smile. Negative people frown. So when I look at this particular function and I notice my a value is negative, that lets me know this parabola is going to frown. So when I think about a frown, and I think about where the vertex sits, this point right here, so I'm kind of like drawing a frown in my head right now. And at the top of that is going to be my vertex, which means that vertex has to be a maximum value. Does everybody see that? Poor people watching at home are like, what's she doing with her hands right now? I can't see. But in general, if your a value is negative, the parabola frowns, the vertex will be a max. If the a value is positive, the parabola smiles, it's a happy parabola, and your vertex would be a minimum. If I want to find the y-intercept, in general, we let x equal 0. So instead of finding f of 2, I'm going to find f of 0. So wherever I see an x, I'm going to go ahead and put in a 0 this time. Well, 0 squared, that's 0. Plus 4 times 0, that's 0. Minus 3, I just get negative 3. So that's the point 0, negative 3. And honestly, that's the long way to find a y-intercept when your parabola is in standard form. I'll go ahead and give you a shortcut for tonight. When you go to find the y-intercept and your parabola is in standard form, this number here or this number here always comes from your c value. So a y-intercept is just a point 0, c. X-intercepts, now we have to let y equal 0. And this is why we had to do that entire first half of the chapter. I'm going to go ahead and find zeros of my function, in other words, solutions to the function. This will help me find my x-intercepts. So I'm going to let y equal 0. I have a hunch, just looking at that negative 3, that I might be able to factor this to get that 4 in the middle back out. So I'm going to try to factor it. I always pull out a GCF first. Factors of 3 that make negative 4 in between. Negative 3 and negative 1, right? Use my zero product property to solve. One of my intercepts is at x equals 3. The other one is at 1. Put my y-intercept there. So I just took a little bit of that shortcut for AC grouping. Remember, you could take that shortcut if the A value is 1. Joey? I didn't split negative 4 up. The shortcut for this particular method, Joey, is to look at factors of C that could possibly add to B. Numbers that multiply to give me 3 that I break up in, I break the 3 up. So factors of positive 3 that make negative 4 are negative 3 and negative 1. Now, true story, you know it well. Is every quadratic factorable? So really the other go-to method, you're probably looking at completing the square or the quadratic formula. So just because the problem doesn't factor doesn't mean you quit and go get a sandwich. You have to persevere a little bit. If it's factorable, you want to use the quadratic formula to kind of get those zeros, okay? Delicious sandwiches. Okay, anyway, domain and range for your graph is something you always want to think about. Quadratics, you can plug any number you want in for x, and you will always get a y value back out. So for that reason, we say the domain of our parabolas, for all of them, to be honest, negative infinity to positive infinity. However, the range is restricted because it's a squaring function. We don't get any old number back out whenever you square something. There's restrictions on that. In this case, it's also flipped. So what I notice is a bunch of values down here, but none up top. That indicates to me that our range values are going to start from negative infinity, but stop at that maximum value of 1. 1 is included in the range of our function. And this is in general the process you're going to follow when you go through and do your homework assignment for tonight. Questions about it? Last couple minutes today, I just want you to start setting up that next example as a little bit of practice. And then I'm going to show you the answers as you're going through.